Here we go. We have a question minimal cost. So there is an array of heights of stone and geeks standing at the first stone, and geek can jump to one of the flowing stones I plus 1 till I plus k kth stone, where k is the maximum number of steps that geek can jump into. So we have cost, and cost is calculated by taking absolute difference between I and j. So J is the stone where the geek will land on, and we need to find the minimum possible total cost incurred before the geek reaches the last stone. So in this example, geek standing at the first stone, so no cost occurred till yet. Then geek will jump on this particular stone, and while jumping this particular stone, this cost is calculated by taking the absolute difference. So the absolute difference is 20. Then from here we can take 3 steps. So he will directly jump to the last stone, and the cost incurred is 10. So the total cost is 30. So we need to find the minimum cost. So the minimum cost is 30 in this case. And in this case, we can only take one step. So geek stands at the first stone, then geek will jump the next stone onto the next stone, then 10 cost will incur, then onto the next stone. So total cost is 20. So that's about the problem description. Let's build the approach. We have this question, we have this test case. So here the geek can jump, the geek can take 3 steps. So suppose geek standing at this particular location. So geek standing at this particular location, he can jump to this cell, he can jump to this cell, he can jump to this cell, and note. Uh, so that's about this particular position. If geek is standing at this particular position, so he can take this step, but then he cannot take further steps. So while we stand at this particular at any given position I, we will calculate we will calculate the position, the the leftmost position. So either either the value is 0, either the value is 0 because we cannot go below 0, or this is I, and I minus k is 3, so 4 minus 3 is 1. So either I minus k, either 0 or either I minus k, whichever is the maximum, we will go till that index. So while geek stands at this particular position, the cost incurred is 0. So then geek stands at this particular position, and he will come from this position. So total cost to reach this position is 0. Then from that particular position, we will jump to the ith position, to the ith position. So here the value is maximum. So only one step we can take on this location. So while we are at this location, we can jump from this index. So the cost that we have to bear to reach this index is 20, and from this index to reach this ith index, the cost incurred is 30. So 20 to reach this and 10 to reach this. So the answer is 30. Initially our dp arrays contain dp array contains maximum value, but as we go we will try to find the minimum value. So we have taken one step. So can we uh, take a step from here? Yes. So the total cost, the minimum cost incurred to jump from this index is 0. So we will jump from this index. So the total cost will be 0 plus 30 is 30. So the minimum answer is 30 to reach this position. To reach this position, either we can take a jump from this. So the cost to reach this particular position is 30, and 10 to reach this position. So the answer is 40 now. So we try to jump from this position. So cost to reach this position is 20, then jump to reach this position is also 20. So the value will be 40 itself. Then we try to jump from this particular position, so the to reach this position is 0, and we try to jump from this particular index. So the answer will be 0 plus 40 is 40 itself. Then from this index, either we take a step from this index, so the cost will be 40 plus 30 is equal to 70, or we can jump from this index. So to reach this index is 30, and to jump to this index is 20. So the minimum answer will be 50. So we'll update our answer. Then we try to find our answer while jumping from this particular position. So to reach this position is 20, and to take a jump from this position is 10. So 20 plus 10 is 30. So we'll update our answer, and the answer is 30. And that's about it. We need to reach the last index. So answer, the minimum answer stores on the last index. So we will return this value. So let's code this. So first we need to find n, then dp, then we will feed the dp. Then on the first location, the cost incurred is 0. Then we try from 1 onwards, and we can take a step from I minus 1, and we will move back. The maximum we can go is 0 or I minus 1, whichever is the maximum. We can uh, take a jump from that particular index only, and not below that. So this is the difference. DP jump means the total minimum cost to reach the DP jump position, and then from that position, from that jump position, we will take a jump from the jump position till the ith position. So that's the cost that we have to include, and it is given we need to take the absolute. So this is the difference. Then we need to fill up the minimum answer on the ith location, and at the end just return the last cell. So let's give it a try. Let's talk about time and space complexity. It is pretty clear. The time complexity is n, and here we have a loop till k. So the total time complexity is n cross k, and space complexity is order of n. So that's about it. Give this video a thumbs up, subscribe to this channel. If you guys have any doubt related to this particular question, comment down below, and thank you all for watching.